For section 4.2, we're going to be looking at solving systems in three variables. We're using elimination. So now instead of an x and y, our equations are going to have an x, a y, and a z. Now this is what a system in three variables looks like. So each equation has an x, a y, and a z, and because there are three variables, there are three equations, and that's the rule. Now, when you solve these, you're going to use your elimination, and if you follow along, I'll walk you through solving this. It's actually pretty easy. You just have to be careful not to make a small mistake. The first thing you want to do is create a lowercase t. These four quadrants are going to be what we use to kind of organize our thoughts as we work through this really long problem. And the second thing that you want to do is you want to take the first two equations and carry them over into this quadrant, and then you want to take the last two equations, these bottom two equations, and you want to carry them down into this quadrant. So the first two equations go up here, the bottom two equations go over here. So that middle equation gets repeated. You'll use the middle equation here, and that's fine. So let's do that first. Now at this point I always double check to make sure that I'm not making a transcription error. So I've got negative 3x, positive y, negative z, and negative 2. And then check the second one, 2x, negative y, negative 2z, negative 12. If you drop a negative sign or forget a positive sign or a number, your whole problem will be messed up. So it's important that you double check for your transcription errors. Now I'm coming down here, and when I get down here, what I'm going to do is I'm going to carry those bottom two equations over into this quadrant. And then once again, I'm going to go ahead and check for any transcription errors. So I've got positive 2x, negative y, negative 2z, negative 12. And then I've got 4x, 2y, positive z, and 1. So once you've carried your four equations over into their quadrants, what you're going to do next is you're going to decide which one of the three variables you want to eliminate first. So we could eliminate x's first, we could eliminate y's first, or we could eliminate z's first. And it doesn't matter which one we choose, but the rule is whatever I eliminate from these two equations, I have to eliminate the exact same thing from these two equations. I'm going to go ahead and choose y's. Why am I going to go ahead and choose y's? I'm going to choose y's because my y's are already going to cancel right here without me having to multiply by anything. Now down here to cancel my y's, I'm going to have to multiply by something, but that's okay. So I'm going to cancel y's. Now remember, if I cancel y's from up here, I'm going to have to cancel y's from down there. You have to cancel from the same thing. So to eliminate, we go ahead and make sure we've got one positive, one negative, which we have, and you add down. So this becomes negative 1x, my y's cancel, negative 3z equals negative 14. Now that negative 1x, that negative 3z equals negative 14, this equation right here, we're going to actually carry it down into our fourth quadrant. So the negative 1x, negative 3z equals negative 14, we bring down here. Now I need to come over into this quadrant. If I canceled y's from up here, I have to cancel the y's from down here. Now to cancel the y's from down here, I'm going to have to multiply by a 2 on the top. I've got a positive 2 in the bottom. I need a negative 2 in the top. So what I'm going to do is I'm going to actually multiply this entire top equation by a positive 2. And I'm just going to carry it and write it underneath this first equation. So if I multiply it by 2 there, by 2 there, by 2 there, and by 2 there, I get 4x minus 2y minus 4z equals negative 24. Now we're ready to eliminate my y's, because if you'll look, I've got a positive 2 and a negative 2, so they're ready to go. 4x and 4x is 8x. My y's cancel just like I thought they would. Z minus 4z is negative 3z, and then I get a negative 23 right here. So 8x, minus 3z equals negative 23. And just like we did on our last one, this equation pops up into this fourth quadrant. Now, once you get to this fourth quadrant, what you're going to do is you're going to decide which variable you're going to eliminate now. So now that we've got the y's gone, we're going to start the whole process over and we're going to eliminate another variable. Well, in this case, it looks like the z's are going to work out the best because I've got a negative 3 and a positive 3, or a negative 3 and a negative 3. All I'm going to have to do is multiply by a negative 1 to change one of those signs. So I'm going to go ahead and multiply this top guy by a negative 1. That's going to change that to a positive 3 so I can cancel those z's. So it's going to be positive 1x, positive 3z, positive 14, and I'm ready to add down. So this becomes 9x equals, and then a negative 9 with my z's canceling, or x equals negative 1. Now x equaling negative 1 is great, but that's only 1/3 of my answer. I still have to get my y and my z. So the way that we do this is we're going to take this negative 1 that we just got, and we're actually going to plug it straight up into this equation right next to it. So instead of 8 times x, it's going to be 8 times negative 1 minus 3z equals negative 23. Well, 8 times negative 1 is a negative 8. If I add that 8 over, I get negative 3z equals negative 15, or z equals a positive 5. So if I solve this out, I get z to equal a positive 5. So if I come over here to my answer, I've got a negative 1 for x, and I've got a positive 5 for z. What am I missing? Well, I'm still missing my y. So to do that, I'm going to take this z of 5 and this x of negative 1, and I'm going to plug both of them into this bottom equation way up here. So instead of 4 times x, it's going to be 4 times negative 1, or negative 4. Instead of a z, it's going to be a positive 5. And what I'm going to do is solve for my y. So negative 4 and 5 becomes 1. If I minus that 1 over, I get 0, and if I divide by that 2, I get my y to be 0. So if I come down here to my answer, I've got negative 1 for x, 0 for y, and 5 for z, giving me my solution. This one point satisfies all three of these equations.